Hi, this is video number 7 for AP Physics C Mechanics Calculus Skills Derivation. And in this video, we're going to be taking the derivative of this velocity function. And it's quite actually an important function that you will be deriving in Unit 2 for forces, something called the resistive force. Before in Physics 1, you didn't have to worry about your air resistance or drag or anything like that. But in this case, in this class, you will have to, right? So in this example, you just have a block, it's falling, and then you have some Fg attached to it, and you have some resistive force attached to it, which can be modeled by mg minus kv equals ma. However, this video isn't about deriving this equation right here, but rather taking the derivative of it, right? And taking the derivative of this seems kind of daunting at first, but ultimately isn't that bad. And the way I like to solve these complicated functions is by looking at if there's any constants, right? So I see right here, this would be a constant, so I don't even have to worry about it, right? So, and what I can do is I can just now focus on this right here, multiply this by -1, e to the negative bt over m as my v of t. Now, I'm really focusing on that, right? In this case, the derivative of something of e to the ax equals a e to the ax. You take the derivative of it, right? And we take the derivative of this, we would get g e to the negative bt over m, because we would then have the negative b over m, this all cancel out. And then this would be our acceleration as a function of time. And then we can check this real quick, plug in a really large number, let's just say like 1,000, right? E to the negative 1,000 gets us 0. And after a long period of time, this velocity is going to stay the same, right? And we said that dv dt, your change in your velocity, is going to equal your acceleration as a function of time, right? And in this case, that is true regardless of the constant that's right here, right? 9.8, even if it was like 100,000, right? For g, wherever that may be the case, it would still be the acceleration going to 0 as kv eventually equals mg, right? And that is kind of the point of the derivation in Unit 2, but this video is essentially just covering how to take the derivative of more complicated, complex functions like this. And it's always by looking for these constants that you can just cancel out or take the chain rule of, right? And in this case, we found it right here by taking the derivative of this. We notice that the b and the m's both cancel out with each other. And that's pretty much it. Thank you for watching, and have a great day.